I guess so. Can you see me from here? All right. I want to check because a while ago. Can you see me from here? There you go. So because a while ago there was no volume. Yeah, no sound at all. So I'm changing it. Now you can see me. I'm here. All right. Okay. So I'm gonna share my screen now. Can you see me? I'm looking at the camera there. All right. So the one that I'm going to discuss with you today is proving that the area of a triangle is 1/2 base times height using a vertical strip. Okay, what is this all about? Proving the area of a triangle is 1/2 BH using a vertical strip. So let's draw a triangle. Okay, and we're going to draw some vertical strips inside the triangle. Oh, sorry. They are not as perfect. So these are vertical strips. They are like cut vertical strips, and we build them this way to make the triangle. So, how many strips did we make? We do not know because we can only say that much if we know the exact measurement at the bottom and the measurement on the y. But y is variable as you can see because it's going that much until it gets its peak and it goes down. Y here is varying, while x could be a constant measurement. Okay? Now, how can integration play in this situation? Let's say the bottom of our triangle is B and the height of our triangle is H. We'd learn from definite integral that area under a curve is the integral of y dx. But because we are using a vertical strip, then the area here becomes the integral of x dy. It's a vertical strip that composes, or these vertical strips compose our triangle, wasn't it? While the y dx would be a small and it goes down, it goes like this until it forms a triangle as well. So there are two ways by which you can analyze a triangle using a horizontal strip or using a vertical strip. Now, this is the one that we're going to do. Okay? So, because dy here is variable, then we're going to make our definite integral from 0 to h. Okay? Because y is our variable, this is our b, and this is our h. Okay? Let's write it again. A is equal to the integral of from 0 to h x dy. Okay. Now, in in this example, let's take this triangle. Can you see that? And the other one will be a big triangle. We have a small triangle and we have the big triangle. The small triangle will have this area where it has a dimension x and y as its height. The big triangle will be the base b and its height h. We can use a similar triangle. Actually, we can cut this here. We can cut it like this. And we will only be using this triangle. Okay? So we can do like that and we can put it here and we can, hang on, hey, oh no. All right, let me see if I can remove that. Very good. There, I have removed it. And because that is red, then that would be the height. And then we can elongate this one. Sorry, it became a drawing class. There you go. It's perfect now. But the B is not. So we better remove this one and draw another. All right. Let's do by similar triangle. By similar triangle. We have of the small one, I'll use another color for that, say green. The x or the base is to the height of the small triangle as the big triangle's base over its height. So that is the base and the base and height against height, or base over height of the small one and base over height of the big one. We need to express x in terms of y. So by cross multiplication, I'll make that one smaller and thinner. X times h is equal to xh, and y times b gives you yb. Okay, let's put it here. Xh is equal to yb. We need x. So x is b over h x is equal to b over h times y. So that is the relationship of x with respect to y. Let's bring this one and substitute it to x. Okay, let's bring this one up, substitute it to x. So you have, I'll make it smaller so you can see a better view. That will be area is equal to b times over h y d1, the integral from 0 to h. It's not written very nicely there, from 0 to h. We can also put the h inside and the 0 over here. There. Or you can do b is constant, h is the one changing. So b and h will just go outside and integrate y dy. So the integral of y dy from 0 to h. And this gives us b over h, y squared over 2 from 0 to h. Let's substitute h to y squared. So you have a is equal to b over h, upper limit h squared. We substituted h into y over 2. This is the upper limit minus the lower limit, b over h, times the y will get the 0 square. The 0 is the next one to substitute over 2. Now 0 multiplied to anything gives you 0. So the only one left will be area is equal to b h squared over 2h. H and 2 cancels out because there are 2 h's here. This is like b h h over 2h. H cancels out. Therefore, area is equal to b h over 2, or it can be written as 1/2 b h. That's what it means. All right, bye.